Good afternoon, everyone. Thanks for coming out. Hope you guys had a great week here at reInvent. We made it to Thursday. My name is Vince Carrion. I'm a senior product manager on the Amazon EFS team. With me today, I've got John Tilt, a senior technical staff member with IBM, as well as Bobby Liao, a senior product manager with TIBCO. And we're really excited to talk to you today about how to build a scalable and highly available messaging service using IBM and TIBCO using Amazon EFS. So today we're going to talk a little bit about Amazon EFS. I'm then going to get off stage and let John talk a little bit about IBM MQ, as well as their journey with Amazon EFS. Bobby then is going to talk about TIBCO EMS, as well as their journey with Amazon EFS. And then we'll leave some time at the end for any Q&A that you guys might have. So let's jump right on in. So first, what do you think about when choosing a storage solution? Well, there are really three things that you should think about. One, what type of storage makes the most sense for how your application is or will be written? The different storage options have different permission models, different semantics, etc. Also, what are some of the features and performance of the various storage options that you're considering, and how does that meet your needs? And lastly, of course, you want to think about the economics of the various solutions. So, there are generally three types of storage: file, block, and object. Now with file storage is data that is stored as files in a directory hierarchy with a particular metadata associated with each file. In other words, your data is stored natively in a file system format. Now in the enterprise context, you can think of it as the data is accessed over a network by multiple clients at the same time. And you can think of that as network attached storage. Now with block storage, it's a disk or set of disks in which your data is stored in chunks called blocks. Now this disk or set of disks is attached to a single computer. And you can have your operating system work with block storage such that the operating system presents the data in a file system format while storing that raw data in blocks. And you could think of this as locally attached storage. Now with object storage, data is stored in a container called an object that is identified by a unique key. And all objects are stored in a flat space. In other words, it's not in a hierarchical structure. And it provides a simple API to get and put data based on key. And commonly, that API is called over the internet. Now, why is file storage so popular? Well, file storage is popular because it works natively with operating systems. Operating systems are designed around file storage. File systems are the abstraction used for displaying data to end users, and operating systems provide file APIs to allow applications to access that data. File storage is popular because it provides shared access while providing consistency guarantees and locking functionality. Guarantees on how your data is updated and the ability to take a lock on a file or part of a file is super useful for distributed applications with multiple readers and writers on that same set of data. And lastly, file storage is popular because it provides a hierarchical namespace. And a hierarchical namespace is super helpful and natural way to think about and organize your data. Now, another aspect you want to consider when performing the various storage types are the performance of those options. So with block storage, it's generally the lowest latency storage type, but it doesn't necessarily scale to the throughput levels of file and object. Block storage is ideal, for example, for database applications that are typically latency sensitive and commonly that database is run on a single computer. Now with file storage, it's generally designed for low, consistent latencies, but is also designed to scale to tens of gigabytes a second of throughput. Now with object storage, it provides the highest level of throughput scale, but it's not necessarily designed for latency-sensitive applications. So about a year and a half ago, we launched Amazon EFS. And before EFS, if you wanted a file storage on AWS, you had to do it yourself. So here's an example of what that might have looked like. Well, you'd want to have it at least in multiple availability zones. So here we're showing 2 for failover and data durability purposes. You'd have a file server running on an Amazon EC2 instance, and you'd have storage volumes attached to those instances. Data would be replicated synchronously or asynchronously across those availability zones, but you would be responsible for managing the file servers, managing the disks, replicating your data, and managing that failover. But now we have Amazon EFS, which is our native, fully managed file service. So when we designed Amazon EFS, we had 3 core tenets. We wanted to make it as simple as possible, we wanted to make it elastic, and we wanted to make it scalable. And this was on top of a foundation of high availability and durability. So what makes it simple? It's fully managed. There's no hardware, network, or file layer. You can create a scalable file system in seconds. We also made pricing simple because we understand with simple pricing comes simple forecasting, and we'll get to that in a second. In terms of elasticity, your file systems grow and shrink automatically as you add or remove your files. There's no need to provision storage capacity or performance, and again, you only pay for the storage that you use with no minimum fee. Scale-wise, file systems can grow to petabytes of capacity. Your throughput scales automatically as your file systems grow and supports consistent low latencies regardless of your file system size. Your EFS file system also supports thousands of concurrent NFS connections. And again, we designed Amazon EFS to be highly available and durable. Every file system object is redundantly stored across multiple availability zones in a region. And it's designed to sustain an availability zone offline condition. It's superior to traditional NAS availability models and is appropriate for production or tier 0 applications. We designed EFS to serve a vast majority of file workloads covering a wide spectrum of performance needs. Everything from big data applications that are massively parallelized and require the highest possible throughput to single-threaded, latency-sensitive workloads. Here are some of our customers who are using the service and for some of the use cases that they are. Now, EFS provides a variety of mechanisms to control access to your data and your file system resources. You can control your network traffic using Amazon VPC security groups and network ACLs. You control file and directory access using POSIX permissions, admin access using AWS IAM, and as of August of this year, we launched encryption of data at rest, which allows you to encrypt your data using a key managed by KMS. You can access your EFS file system from a variety of environments, including Amazon EC2 instances in your VPC, servers in your corporate data center through Direct Connect, and announced this week, you can access your EFS file systems through VMware Cloud on AWS software-defined data centers. Let's talk a little bit about the economics. Again, we talked about you only pay for storage that you use. There's no minimum commitment, there's no upfront fees, don't have to provision storage in advance, and you can see our pricing across regions. Now let's put that price in context. So earlier we talked about the do-it-yourself model. Doing it yourself not only can get complicated, but it can also get pricey. You have Amazon EC2 instance costs, EBS volume costs for the storage, and then inter-AZ data transfer costs. Using an example of a 500 gigabyte file system, with Amazon EFS, you only pay for the storage that you use. And in this example, $150 a month, or 70% less expensive than the do-it-yourself version. Again, it's a fully managed service. Amazon EFS is available in 6 regions today, with more to come. And it's a core part of a rich set of storage building blocks, which is complemented by a variety of data movement and data security and management tools. one of which we announced this week, EFS File Sync, which allows you to quickly and easily sync and move your data into your EFS file systems from your on-cloud or your on-prem file systems. But you're here to learn about messaging and hear about IBM and TIBCO. So what is messaging? Messaging integrates data and applications across multiple environments: cloud, IoT, mobile, on-prem, and it's the processing of real-time data in motion. So with that, I'd like to bring up John from IBM to talk a little bit about his journey.
Thank you, Vince. Welcome, everybody. I'd really like to thank Vince for inviting me back to Vegas. The last time I was here was 27 years ago. Not a lot's changed, I don't think, except the hotels. They're enormous. Some of these hotels cover more floor space than the town I live in the UK. I'm going to talk a little bit about myself, which I love doing, of course. I'm going to talk about IBM to give you some context in this story, messaging, MQ and how it fits, and then how we've used EFS to underpin our environment. So I'm first of all going to ask you, who knows about messaging? Hopefully all of you. Good. Who knows about MQ? Even better, it's nearly all of the audience. Before I've asked that question, when it's 50-50, I say, OK, well, those of you that know, tell those of you that don't know, and I'll go and have 5 minutes off. But in this case, you all know it. How many of you have used MQ in the last week? Actually, all put your hands up. I'm going to explain why later on, but you've probably all used MQ in some form or shape over the last, maybe in the last day even, without even knowing it. So I'm John Tilt, Senior Technical Staff Member, whatever that might mean, in Hursley. IBM's lab, biggest lab in Europe, we've got about 2,000 engineers based in this lovely country mansion. Dates back to the days of Richard Cromwell. Anybody know who Richard Cromwell was? You probably know his brother. It was a guy called Oliver Cromwell, who was a really radical man and changed the way that people thought about politics in the UK. So we have a history of change. During the war, we developed the Spitfire, probably the aircraft that made the biggest change to the UK. That was developed there. When IBM moved there back in the late 50s, we developed products like the Winchester hard drive, named after the nearest city. MQ and Kix have been going there. So we're not new to innovation. I've been in IBM 30 years. You're looking at me going, I can't believe that. You only look 25, don't you? Yeah, thank you. I've been in the industry all that time. I'm still enthused, still excited about what we're doing in this environment. And I've been lucky enough to be able to lead this piece of work for IBM, working with the AWS team. And it has been one of the most fun times of my full 30 years, actually working in this environment. When I was at university back in the early 80s, we were told the pace of change will slow down very quickly. You know, the rate of change in the 80s is as fast as it's going to get. Well, has it slowed down? No, of course it's not. And that rate of change is carrying on. And it's just great being part of it. For myself, my role is I'm a coach. I coach people to deliver fantastic software. That's primarily what I do. I motivate our teams. I get them doing stuff that's quite extraordinary. Outside of work, I'm a track and field coach as well, so there's a bit of crossover there. I also do a little bit of running myself. I'm ranked #1 in the world in my age group over 400-meter hurdles. So you can see the crossover here is that I value developing people, developing software, and delivering really good performances, be it my people at work, myself, or the people I coach. I'm also studying for a sports massage course at the moment. So you could say I'm a hands-on engineer, but that's probably stretching it a little bit too far. IBM. You've probably heard of IBM. 300,000 plus employees around the world. You are asking the question, what on earth is IBM doing here? Surely they've got their own cloud. Shouldn't they be worrying about their own cloud and not worrying about AWS? The answer is simple. Our customers are moving to AWS. AWS has got a damn good cloud. we need to help our customers. So you'll hear about how we're using our software on AWS as well as our own cloud. Let's take you back 100 years. Even Ori wasn't around in that time. IBM has been around for over 100 years, and through that time, we have seen dramatic change, as you can imagine. If you go all the way back to Hollerith in the 1890s, when he produced the first US census on punch cards, we invented the mainframe with the System 360, we invented the PC, all those sort of great things that have happened during that time. But it hasn't been without trauma. We dominated the industry for a time. The US government didn't like that. We've had our near-death experience. We came back from that. We're always reinventing ourselves, always changing, always looking for new markets, and this time is no exception. Transformation, continuously transforming, is vital to the way all of us do business now. You cannot sit still for one moment. Proud to say that over the last 24 years, IBM has topped the innovation charts. So the number of patents produced by any company in any year has been led by IBM for 24 years. Last year, we produced 8,000 patents. That's the first company to pass 8,000 patents in a year. That's 22 patents a day that we're producing. So we're always trying to innovate, always trying to keep up and get ahead of the curve. Our strategic imperatives at the moment, on the left, Watson, our AI for business. On the right, systems. We are still producing machines. We are still producing fantastic mainframes. The new Z14 has pervasive encryption of everything on the go. We still produce storage, some fantastic storage. And in the middle, the IBM Cloud. Over 40 data centers. We're majoring in public, private, and hybrid clouds. So we got to messaging. What is messaging? Let's just talk generically about what we mean by messaging. It's not WhatsApp. It's not Facebook Messenger. It's not text. This is about business messaging. It's about connecting the business applications that are out there. We have to do it in a secure and stable way. Those of you that were lucky enough to go to Werner's presentation this morning, a quick show of hands, he talked a lot about security first. So important. And it's no different with messages. The sort of messages that we are passing around are your bank transactions, your medical records, things that you don't want people poking around with and changing and doing anything to. We talk about once and once only assured delivery. We don't just fire hundreds of messages out into the ether and hope that one of them gets there. We fire one and we nurture that thing. We nurture it until it gets there, and we care about every single message. And as you'll see when I start to talk about the storage that underpins this, that's why our journey with EFS has been so important. I'm going to pick on also cross-platform. Cross-platform is vital to us. It's no good having a messaging system that doesn't connect multiple platforms because the world is heterogeneous. I have to work that word into every presentation that I talk about MQ. But we will work anywhere and we will connect those platforms. Werner again said this morning, be data-driven. This is the data that backs us up. 94% of the world's top 100 banks, 85% of the Fortune 100, 70% of the Global 500 are already using MQ to underpin their business. The sort of areas, finance, healthcare, government, retail. Again, from this morning's presentation, you heard about an internet bank, and they were talking about how they connect their business to the on-premise business. How do you think they do that in a reliable, secure way? Of course, it has to be MQ. MQ itself simplifies those challenges. The challenges that we have initially, when I first started working on MQ, probably 25 years ago, the challenge was around the unstable networks. Networks were dodgy. We had to do work to help make that good. Networks have got a lot better, but what we're doing now is going outside of the on-premise environment, and we're bringing in the entire internet. So all those challenges that we faced all that time ago are still there, and they're probably now multiplied. So connecting everything is vital. The cloud to us is just another platform. It doesn't matter whether it's AWS, whether it's IBM, whether it's Google, whether it's Azure. It is just another platform to us that needs connecting. We need to be reliable, scalable, secure, flexible, and robust. And all those keywords underpin why we need something really, really secure underneath us. So the first platform we delivered on was our mainframe. It would be, that's our biggest business initially, back in 25 years ago. Anybody know what the second platform was we delivered on? It was OS2. We quickly moved on and got on other platforms. So pretty much any platform you can throw at me, we cover it. It doesn't matter whether it's a variant of Linux, it's Windows, it's another Unix that comes along, we support it because we have to be everywhere. And the cloud is just another platform. Now I'm going to talk about high availability because if you have a service like MQ, you're going to value two things. You're going to value the availability of the service and the availability of the data. Now one thing we do not compromise on is the availability of the data. Those messages, we love every single one of them. We nurture them like they are our own children. We really need to care for them. But all of these things come at a cost. I talk to some people and they think of HA as being some sort of binary. You're either highly available or you're not. Well, no, it's much more of a spectrum. And again, as you saw this morning from Werner, you can talk about 2 nines all the way up to 6 nines. And the solution you come up with to solve that will vary depending on how much you want to pay for it. Here are some of the options that we offer in MQ at the moment. If you have a single queue manager with local storage, well, that offers some level of robustness. It's reliable software. It's been around there a long time. We have a good support team supporting it. But you want more than that. So by separating out the data, you can then remove that single point of failure. We also provide multi-instance queue managers. Multi-instance queue managers will give you a passive-active setup. So if one queue manager goes down, the other one immediately picks up. So you keep the service available as long as possible. In our latest release on 904, MQ 904 that went out about a month ago, you will see that we're doing replication of local data. So that provides a third way of doing it. But all of these come at a different cost. So the left-hand side, 1 queue manager cost, the middle one 2, the third one 3. So you decide what you want to pay and what sort of availability of the service and the data that you want. So I'm going to share where we've come on this journey with EFS together. And our timeline almost exactly matches, which has been great. So I'm going to reiterate, and I don't know how many times I need to say it, but persistence is vital to us. We do not lose messages. That's why we have MQ. We do not lose them. When we started playing around with the cloud 18 months, 2 years ago, because customers were coming to us and saying, we want this stuff, we experimented with block storage, which was fine, did a job, but it didn't give us the levels that our customers were asking for. We looked at setting up Ceph, which again, solved the problem, but it meant that we had to maintain that whole Ceph environment. Then, almost by luck, we heard about EFS becoming available in June. We managed to get on the pilot program to actually get in there and experiment early on, and when it went live in June, we were able to go live very quickly with a solution that showed us underpinning it. So we've come on this journey together, and it's a real pleasure to be able to share the stage here with Vince. Our first setup was very, very simple. Just a queue manager using an auto-sharing group to failover and hooking into that EFS file system. And as soon as the auto-sharing group detected a failure, the MQ server was brought up in the second region, and because the data was nicely, securely stored on EFS, when the second server comes up, everybody's happy and nothing's lost, and the server carries on as if nothing's happened. So it's a key point of our architecture. It's the thing that makes it happen. Now, in this particular example, the queue manager failover takes about 3 minutes. The cost there is nothing to do with EFS. It's just that we, in this case, because we don't have a passive-active setup, the new queue manager needs to be set up from scratch. But the whole model, the whole architecture is simple to set up, has a simple charging model. It's part of the whole AWS ecosystem, which we really like. Built on top of that, we decided to come up with a quick start. Some of you will be familiar with the Amazon quick starts. We engaged and partnered with AWS to help put one of these together for the first time. We were actually the first IBM product to do this, so it's groundbreaking for us and really fun working with the AWS team. We came up with, this is our design thinking. If you've heard of IBM design thinking, we talk about hills. We deliver hills. We take a hill. And we have 3 components to that. We have the who. Who's this for? The what are we delivering? And the wow. And the who, we looked at 3 different types of people. It's the MQ specialist who's perhaps new to AWS and just wants a push-button setup. We have an AWS specialist who might not know MQ, but again wants something simple. Or the application owner who just wants to set something up to test their application. What do you get? You get something nice and simple, very, very quick to set up. If you want to go and give it a try yourself, it's on there. You just click a few buttons, you fill in half a dozen fields, and you're up and running. And the wow is that total time it takes to build is less than 30 minutes. I've seen it done in about 15, which is pretty special considering the complexity of the environment. So we went live back in August. Got a lot of good publicity about that. What it's doing for us is showing our customers that we care. We care about AWS, and we care about setting up production-like environments for them in the cloud. That's a more elaborate picture of what we're doing. I like to think of this as the MQ sandwich, where MQ is the meat in the middle, but at the top layer is we get that nice protection layer, that nice security blanket that keeps out the undesirables. We have a load balancer that only allows in 2 ports, and we can restrict the IP addresses that come in on that. The 2 ports being the admin console on 9443 and the client port on 1414. So nice and secure up there. And then I describe the storage layer at the bottom as being our confidence level. That's our piece that doesn't lose messages when we get the failover. And then, of course, you've got the MQ server in the middle. So in summary, MQ is a key component of every major enterprise. You need to be connecting your applications. You need to be underpinning that enterprise with something reliable and secure. MQ provides that. It's secure, reliable, and robust, and it's everywhere. We are platform agnostic. We will work wherever our customers need it. EFS gives us that availability across availability zones, so it gives us those number of 9s that we're searching for, and it allows us a fast and low-cost failover and utilizing AWS services, which is a real attraction, and there's nothing we then need to own on top of that. If you want some additional resources, there's the Quick Start page. Our developer work site will show you a number of blogs that took us through this journey. So if you think I was making it up, go and read these blogs and you will see exactly that journey that we went through. We used those blogs actually to identify how important this was going to be to us. We had over 100,000 hits in there, which gave us a clue that this was useful stuff to do. And finally, the MQ page. If you want to learn more about MQ, if you want to learn more about the new release, then please go there. Thank you very much for listening. I'm now going to hand you over to Bobby from Tipico. So thank you, Bobby.
Thanks, John. Good afternoon. My name is Bobby Liao. We're talking about typical messaging on AWS. TIPCO, the information bus company, we're based out of Palo Alto, California. Our headquarters is in Stanford Research Park, the birthplace of Silicon Valley. In fact, we're a spinoff from a successful software startup called Techniquant Software Systems. Back in the 1980s through the 90s, we revolutionized technology for Wall Street by introducing the market data distribution system that ushered in the digital era for the investment banks. And since then, we've continued to interconnect and integrate different applications and systems together, as well as people and processes. We help collect and process data in real time. Through streaming analytics, rich visualization, and dashboards, we help businesses gain actionable insights to make faster and smarter decisions. So essentially, we basically interconnect everything and augment that decision-making ability, and this is what we call the connective intelligence. So let me focus on the messaging technology, which is the topic of our discussion this evening. TIPCO is a pioneer in message-oriented middleware. We introduced the concept of publish and subscribe, helping businesses in building massively scalable, event-driven solutions. Applications can subscribe or register interest in a particular topic or subject and receive continuous updates. Today, TIPCO has the industry's fastest messaging middleware, delivering 6 million messages per second per subscriber and the lowest latency. One-way latency between a sender and receiver on 2 different hosts is in single-digit microseconds. The same applications deployed on the same host is 1/5 of a microsecond. Now, it's not just about performance with high throughput and low latency. It's also about reliability and scalability. Our enterprise customers require 7/24 operations, rolling upgrades with 0 downtime. Another reason for our customer success is the fact that our users and application developers can focus on the higher value tasks. That is, in designing and implementing the business logic in their applications and not have to worry about the network infrastructure details. So the applications can be deployed on a number of network topologies by simply connecting the endpoints together with the appropriate transport. And that can be done administratively and not having to recode. And what this means is that the application deployment can be much more flexible and agile, and the application themselves much less brittle. So let me talk about, so let me talk about where TIPCO messaging is used in the different industries. So as I mentioned earlier, financial services where TIPCO began. From the early days of doing market data distribution for capital markets to now retail and institutional banking and insurance companies. The world's largest futures and options marketplace that handles 3 billion contracts a year, a value over $1 quadrillion, that's $1,000 trillion, or 1 with 15 zeros behind, has built their infrastructure on top of messaging, or TIPCO messaging in this case, and operating for over a decade. Now, if you look around the room today, the smartphones that you have in your hands, in your pockets, as well as the laptops and tablets, and all these electronics, the semiconductor components, the integrated circuits in these devices are most likely manufactured in one of the billion-dollar fabs throughout Asia. The manufacturing execution systems that ties all the equipment and processes together for automation and yield analysis are powered by TIPCO. In fact, if you look at the fast-growing flash memory market, which is a $50 billion industry this year, all 5 of the largest flash memory manufacturers are powered by TIPCO. Now, most of us came to reInvent this week by plane. I did, right? And I booked my flight 3 weeks ago online. And 2 days ago, I checked in on an app on my iPhone. And yesterday, I got to the airport. Since I didn't have any bags to check in, I cleared security and went straight to the gate. That's where they scanned my boarding pass, and I boarded the plane. An hour later, I'm here in McLaren. During my journey from San Francisco to Las Vegas, right, my interaction with the airlines were a series of events that were captured through TIPCO and processed. In fact, every single day, thousands of flights, millions of passengers, and their bags and the packages, right, reach their destination, generating billions and billions of events, are all powered through TIPCO. 25 of the world's airlines, including all 5 of the largest airlines, are powered by TIBCO. So as you can see, it's quite exciting for me to be working with the TIBCO team and the customers who are the digital leaders in their respective industries in building these event-driven solutions and creating personalized experiences for their customers. And I, for one, is also one of their customers. So the bank that I use for my checking and market savings account, the mutual fund company that manages my 401k, the insurance company that underwrites my auto and home policies, the restaurant that I order my pizza from, right? As well as the utility company that monitors my energy usage through smart meters, and the hospitals, right, that has the state-of-the-art medical equipment, all embed TIBCO. And let me just share one more industry with you, which is the hospitality industry, one of my favorite. So right here in Las Vegas, right, the entertainment capital of the world, the city never sleeps. On the Las Vegas Strip, the top casino operators and resort operators, they want to create the best customer experience possible for us. So we may extend our stay or perhaps come back more frequently. So from the moment we check in to booking a show, to dining in one of the restaurants, as well as hitting the slot machine and casino floor, all these events, all these interactions we have with the casinos and hotels are also processed through TIBCO. So TIBCO really, it's about interconnecting, everything, anywhere, and everywhere. So let me switch gear and talk about the technology behind the digital transformation on AWS. TIBCO FTL, faster than light. Although TIBCO engineers haven't quite figured out how to break the laws of physics yet, but our customers have come to expect that the latest generation of messaging technology is faster, tougher, and lighter weight than ever. We've designed FTL for both on-prem and the cloud, so there's no special infrastructure requirements. We provide Docker images, so you can deploy your infrastructure components much quicker for both private and public cloud. All the high performance that I talked about, as well as the enterprise feature for disaster recovery replication, all available and supported on AWS. And last month in San Diego at TIBCO Now, our user conference, we announced TIBCO Cloud Messaging, which is messaging as a service, fully managed by TIBCO, and it's hosted on AWS. TIBCO Cloud Messaging provides publish and subscribe messaging with content-based subscription. We support secure WebSockets. SDKs include Go, Java, JavaScript, Node.js, C#, as well as native mobile support for iOS and Android. Now, about 18 years ago, TIBCO, IBM, as well as other messaging middleware experts came together and contributed to a specification known as Java Message Service, or JMS. TIBCO Enterprise Message Service, or EMS, is a JMS implementation. Every release of EMS is TCK certified to ensure 100% JMS compatibility. We've also added extensions to JMS for enhanced usability as well as customer requirements. And a lot of customers are looking to move their infrastructure to AWS. So we've been working with the AWS team this past year to ensure that we can deploy the entire EMS infrastructure on AWS. So let me talk a bit more about the architecture for EMS on-prem. So as a JMS provider, the EMS server handles all the messaging communications. We deploy a fault-tolerant pair, primary and standby. When the primary goes offline or is brought down for maintenance, through a configurable heartbeat mechanism, the standby takes over as primary. And all the EMS applications will reconnect automatically through the client libraries. Now, the pair of EMS servers require a shared storage device. Okay? Instead of requiring our customers to use a particular solution, we allow our users to choose their own cluster server or a cluster file system in combination with their own storage area network or network-attached storage. As long as the solution can support the 4 published criteria that covers write order, synchronous write persistence, distributed file locking, and unique write ownership, right? So as long as the storage solution can support all those 4 criteria, then we're good to go. So what that means is when our customers migrate, right, or lift a ship to AWS, their EMS applications and the servers are running on AWS, and they will also need to have that shared storage, and in this case, it's EFS. So a little bit more detail, you will configure and run a primary EMS server in one availability zone, and then a standby in another availability zone, right? And then again, the configurable heartbeat mechanism between the two. And they use EFS as the shared storage, right? And that's used to persist data for guaranteed message delivery, for queues and durable topics, as well as metadata and session information for the clients. And then, of course, the EMS applications can be deployed in one or the other availability zone. Now, another important scenario for our customer is one that some of them may be migrating their application or infrastructure onto AWS in phases. So what that means is some of their EMS applications will continue to run in their private cloud, on-prem, in their data center. So with this hybrid cloud architecture, their applications can securely connect to the EMS infrastructure now running on AWS through AWS Direct Connect. Another important scenario, as many of our customers have global deployments, their EMS infrastructure is deployed across different geographies. So for instance, from New York to Amsterdam to Tokyo. Now, one of our customers is migrating from their data center in Europe right onto AWS. What we have is a out-of-box routing capability, right? As their applications are running locally, connecting to their local EMS infrastructure, we have routing, we are able to route the messages by destination to the other data centers. So as one of their first data centers move to the AWS, they can still get that seamless integration as all the applications can be routed where the messages cross. So in summary, our customer's journey from on-prem to the cloud, I'm very pleased to announce that TIBCO EMS is now fully supported on AWS using EFS. The important thing here is that with that seamless integration, two very important benefits our customers get is that having the EFS fully managed by AWS, they can get that persistent, predictable, consistent performance, as well as lower infrastructure cost, which translates into lower TCO, and that will certainly bring smiles to their CFOs. And lastly, I'd like to invite you to check out EMS on Tap, TIBCO Access Point, where you can download our software. Our quick start guide is being worked on. We're about to finish it probably next week. We'll be submitting that to the AWS team for review, and shortly after that, it will be published. And also for those of you who are interested in learning more about TIBCO's messaging technology, as well as our TIBCO Connected Intelligence, I'd like to invite you to join us online, community.tibco.com. Thank you.
Well, thanks a lot to Bobby. Thanks a lot, John. I really appreciate you guys coming and sharing your experience. As you can see here, we're at the last session for EFS for the week. So unfortunately, there will be no more sessions. However, these sessions will be available online for you to view later. With that said, again, I'd like to thank Bobby and John for coming out here and sharing their story with us. And if we have any questions, we'd love to take those at this time. Sure. Do we have a microphone?
You can hear me now, right? Okay. The question is, we use MQ, and then we appreciate that MQ works pretty well on the on-prem and on the cloud, all of that. But from the AWS services, when we try to understand that you already have SQS as a service, which is a fully managed, scalable SQS service. So how does the MQ on AWS look like in comparison with the usage of SQS as a service?
Sure, I can answer that. Did everyone hear that question? So the question was, how does the new MQ service from Amazon, how does it compare? And how does it, I guess, compare with SQS? Okay. So it is a new service. There's a lot of opportunity in this space. So we really don't see that, we have a lot of partners running this space as well. There's a lot of opportunity to have multiple solutions, really depending on what the customer's needs are. So we feel that the space is large enough that we can have our partners our new MQ service, SQS, in the same space, giving our customers the functionality that they need based on the requirements. So we don't see that they're really being competitive. It's more of just giving customers another option to use in their environment. Great. Any other questions? It's blinding.
You mentioned that you just recently introduced a file sync methodology to EFS. I'm curious to know, one of the things with EMS as an example, and I know MQ uses a similar model, is that on-premise services typically write to a local file system. What are the guarantees that you have with that synchronization process, and is that something that could potentially be used to help migrate an on-premise type of messaging queuing service or messaging middleware into the cloud using these services?
Thank you. So just to give you a little more background on the EFS file sync that we released last week, it is it's a one-way synchronization from, say, on-prem over to an Amazon EFS file system. It's not a continuous synchronization process. It's actually executed through the management console. You set up an agent on-prem, you create a sync set, then you manually execute that sync set within the console. Depending on the options that you select when you create that sync set, or even when you run the task, you can tell it to have to be full consistency. What will happen then after the sync, basically after that copy is made, it will do a verification, source and destination to see if there's any changes. If there's any changes, if it's a full consistency and everything is good, it'll show success. If it doesn't, it'll show failure. So one process is, if you're going to be doing multiple syncs, disable the full consistency, run the sync. It'll run very quickly. It's not going to do the verification at the end. Then when you want to make sure that it's consistent, enable full consistency, run that check, and then it'll verify that source and destination are in place. But again, this is a manual process today. It is a new service. It's only a week old. So there's getting customer feedback from you on some of the features that you would like to see, I think is very, very important. Any other question? Yeah.
I got two questions actually, but let's start with an EFS question, so I'm happy you're here. We use EFS, but we have a star model, so that means we have a shared services VPC or surrounded by other VPCs. They are all paired to the shared service VPC. We offer DNS services from out the shared service VPC, but now we have a problem because EFS will not work on DNS in the other VPC surrounding it, because it will go to the central DNS, try to resolve the EFS endpoint, what will not work. Is it somewhere on the roadmap to fix this?
So before we get to that, Daryl, if you don't mind, could we go with did you have a separate question for the perhaps IBM and TIBCO team, and maybe we could talk offline on any specific EFS questions? Would that work?
We can maybe do it later.
Great. Perfect.
Then I have another question. Why not use a database instead of the EFS solution? Database is also consistent, read-write, whatever is needed. Sorry, rephrase my question. What do you recommend, to use a database or to use EFS? Because I think both will be supported.
So a database is a very different model to messaging in that a database tends to be write once, read many, whereas with messaging, we are writing, reading, deleting on a rapid basis. So it is a different model. We have, I'm sure TIBCO have done the same, explored actually using databases as the underpinning environment, but hasn't worked out as well because of the performance. So what we're tending to do is have our own writing to disk methodology, and we get a lot better speed out of it.
Thank you.
Yeah, and I agree with John. For TIBCO as well, I think for EMS, we support different data stores, so certainly database is an option. And we do have customers doing that, but they are mindful of the fact that it's not as performant as being, using a file base or file storage.
Yeah, perfect. We use TIBCO actually, so we're looking for the database, but I understand you can better use the EFS option. So thank you for that.
I would love to address your question after the session. Perfect.
Okay, this is for TIBCO. So a requirement is for high availability would be the shared storage. It's there now, so that's great. Was there any need for you to kind of tweak TIBCO EMS for EFS?
In our case, no. As I mentioned earlier, we have that 4 published criteria. As long as the file system with the storage solution can meet that, we can fully support that. In terms of fine-tuning all that, oftentimes it has to do with more on the EMS server side, how you can partition your destinations with queues and topics. So there are ways of doing that. But again, EFS does meet those 4 criteria and really makes it easy for all our customers to do that lift and shift onto AWS.
Hello. Hi, this question is for IBM, John. I'm from Fannie Mae. We're using your, have you heard the Symphony product from your IBM?
The what, sorry?
The IBM Symphony system. It's distributed high-performance computing system developed by IBM.
No, I'm sorry, I haven't heard it.
Okay. Have you heard the HPFS, high-performance share file system developed by IBM?
I have heard of it, but I won't pretend that
we have on-premises distributed computing environment that has tens of thousands nodes that exchange data using a shared file system. They are very high the rating speed is fantastic. So we're looking for this kind of file system in cloud when we migrate our, our software, which is used to calculate some financial modeling. It's very highly sophisticated. It takes a lot of CPU, thousand CPU, and run hours on the on-premise. We're looking for this kind of things to AWS. That's why one thing is it has to have a shared file system across thousands nodes to have to write there and very quickly, and you read it back by another 1,000 nodes. The second is we are looking, they are all coupled, all the process. It has to exchange data on the fly, a gigabyte of data for each object. So another process, 10,000 process has to take an instance that has to take the message and deserialize to the object and do processing. So that's what I'm saying. By using this, your IBM MQ system, can you deliver this kind of object in messaging, like gigabyte of data, like each object from between the instance that run on the cloud?
So is your question about passing very large messages around?
And that's what we're using currently on premises using IBM product called Symphony. They're doing very well, but we're looking for because for whatever reason that we decided to move to cloud, to AWS. Right. But I'm looking for around this kind of thing in cloud. It just nothing can perform that kind of level.
It's not something so far that we've come across or that we've experimented with, but it's a valid use case, and it's something that we need to look at. Something like Aspira, is that something that might help?
Sorry, what?
Aspira. Have you come across Aspira?
I don't know.
Okay, that will move large amounts of data very quickly around.
But what size normally the messaging system you develop, the MQ, IBM MQ on the cloud? Is all small messages, or that can be used to transfer data? What?
We will process the messages of all size. A gigabyte is starting to get very, very big. And you're probably looking at something like managed file transfer to move that. I'd have to talk offline, I think.
Last question. Do you have API, a C++ API for this messaging?
An API for messaging?
Yeah, already in C++ library.
We have the MQ API. We have the JMS API. Is that what you're meaning?
Okay. All right. Okay.
A number of different APIs of getting in there. Okay.
Okay.
All right. Thank you.
I have a product roadmap question. So any plans to integrate IBM MQ and Amazon MQ in future? Or maybe for Amazon, any plan to have a RDS-like feature for messaging?
Yep.
So we don't stuck with managing.
Hey, Daryl.
Sure.
I think.
Hi, I'm Trevor Dyke. I'm from the messaging team in Amazon. So, yeah, as you said, we launched Amazon MQ this week, which is a managed broker service for Apache ActiveMQ, which is an open source product. So we don't have any current plans to do that, but it is a possibility down the road. IBM MQ and TIBCO are both great partners and are running on Amazon infrastructure. And as a gentleman here said, we think this is a huge space and there's room for lots of players in this space. And it's just a growing market. So, you know, both of the gentlemen here, the products have been around for 20, 25 years. Is that right? So they're extremely feature rich. And, you know, there's many customers that, you know, like some of the folks in the room here that will need to stay on those platforms. So it's something we're open to. It's not something that we are currently planning just yet. Thanks.
Cool. Any more questions? Cool. Great. Well, thank you so much for your time. Enjoy the rest of the week.